Alright, today we're going to continue on with section 10.5, and we're going to look at the power reducing and the half angle identities. I apologize ahead of time if I sound a little nasally. I'm a little stuffed up today, but I'm going to power through. So, what can I do to reduce a power? That's a great question. I'm glad you asked it. So first we want to ask ourselves, well, what identities that we've seen already have two different powers in the equation? That's how we can help figure out how to reduce a power. And what should hopefully come to mind are your double angle identities, specifically the cosine double angle identities is what I'm referring to. So for instance, if I know the cosine of 2 theta is 2 cosine squared theta minus 1, and if I do a little basic algebra, I can solve this equation for cosine squared theta, and I end up with cosine squared theta is 1 plus cosine 2 theta over 2. So that's how I can reduce the power of cosine. If I have a cosine squared, I can put it into cosine to the first power by using the power reducing identity. We can use the same double angle identity to reduce the power of sine. So we know that cosine of 2 theta is 1 minus 2 sine squared of theta, and therefore sine squared theta is 1 minus cosine 2 theta over 2. So there I can reduce the power of sine to a first degree. Well, what about tangent? Well, tangent, remember, is sine over cosine. So I know tan squared theta is sine squared theta over cosine squared theta. What we just saw from our power reducing, sine squared is 1 minus cosine of 2 theta over 2, and cosine squared is 1 plus cosine 2 theta over 2. The 2's are going to reduce, and so I'm left with 1 minus cosine 2 theta over 1 plus cosine 2 theta. So that's the power reducing identity for tangent. So then I know the next burning question on your mind is, great, well, what the heck is a half angle? And that's also a great question, and we can look at this by taking for instance, the sine power reducing equation. So if I say we know sine squared of theta is 1 minus cosine of 2 theta over 2. Well, what if I take the square root of both sides because I don't like sine squared? Then we're going to end up with sine of theta is plus or minus the square root of 1 minus cosine of 2 theta over 2. But now I don't like having the double angle in here. So let's come up with a new relationship. Let's say let x equal 2 theta, then x over 2 is theta. So that's my half angle. So now my relationship is sine of x over 2 is plus or minus the square root of 1 minus cosine of x all over 2. So this is how we can develop the sine half angle identity. So now let's look at all of the half angle identities. So sine of x over 2 is plus or minus the square root of 1 minus cosine of x, all divided by 2. Cosine of x over 2 is plus or minus the square root of 1 plus cosine of x, all divided by 2. And tangent of x over 2 is 1 minus cosine of x over sine of x, or sine of x over 1 plus cosine of x, or plus or minus the square root of 1 minus cosine of x over 1 plus cosine of x. So as you're looking at these, you're like, great, plus or minus. How do I know if it's going to be the plus or minus? Another good question. It's pretty simple, actually. You just need to ask yourself, what quadrant is x over 2 in? So, for instance, if x over 2 is in the second quadrant, then sine is going to be positive, so I would use the plus. But if x over 2 is in the second quadrant, then cosine is going to be negative. Tangent would also be negative. So that's how you know to use the plus or minus, is which quadrant does the half angle fall in. Alright, so now let's look at an example of the power reducing formula. So I want you to try and rewrite the expression sine to the fourth power of x times cosine squared of x in terms of the first power of cosine. I want you to pause the video and unpause when you're ready to check your work. I will warn you, this is going to be a little bit of work. This isn't just a two-step problem. So you're going to continue to use the power reducing formulas until everything is into the first power of cosine. So pause, unpause when you're ready to check. Okay, so first recognize sine to the fourth x is sine squared x times sine squared x, and then I still have the cosine squared x. Alright, now for each one of these, use the power reducing formula. So sine squared of x is 1 minus cosine 2 theta. Sorry, it should be x. I switched it to theta. That's not important. Sine squared of x here is also 1 minus cosine 2 theta over 2, and then cosine squared of x is 1 plus cosine 2 theta over 2. I apologize. It is important that I keep the angle correct, but I switched it here as long as the algebra is the important part. So, continuing on, I digress. Multiply these two together. So 1 minus cosine 2 theta times 1 minus cosine 2 theta is 1 minus 2 cosine 2 theta plus cosine squared 2 theta over 4, and I still have 1 plus cosine 2 theta over 2. Now multiply these together. So distribute. So 1 times 1 gives me 1. 1 times cosine 2 theta is cosine 2 theta. Negative 2 cosine 2 theta times 1 is negative 2 cosine 2 theta. Negative 2 cosine 2 theta times cosine 2 theta is negative 2 cosine squared 2 theta. Cosine squared 2 theta times 1 is cosine squared 2 theta. Cosine squared 2 theta times cosine 2 theta is cosine cubed 2 theta. 4 times 2 is 8 in the denominator. Combine like terms in the numerator, and I end up with 1 minus cosine 2 theta minus cosine squared 2 theta plus cosine cubed 2 theta. Okay, so I still have a second degree and a third degree. So with the second degree here, cosine squared 2 theta, I'm going to use the power reducing formula again. Now this becomes 1 plus cosine 4 theta over 2. So the angle always gets doubled. Since this was 2 theta, now it becomes 4 theta. Cosine cubed 2 theta, I'm going to split this up into cosine of 2 theta times cosine squared 2 theta. So that's how I end up with cosine 2 theta and then times 1 plus cosine 4 theta over 2. Now I split everything up and distribute, so this negative becomes negative 1/2 minus cosine 4 theta over 2. Cosine 2 theta times 1 divided by 2, you get cosine 2 theta over 2 plus cosine 2 theta times cosine 4 theta over 2. Since these are not the same angle, I can't combine them, so that's actually nice and makes the problem a little bit easier. Now I chose to multiply the top and the bottom by 2 to get rid of the fractions in the numerator. So I end up with 2 minus 2 cosine 2 theta minus 1 minus cosine 4 theta plus cosine 2 theta plus cosine 2 theta times cosine 4 theta all over 16. Combine like terms in the numerator, and I get 1 minus cosine 2 theta minus cosine 4 theta plus cosine 2 theta times cosine 4 theta all over 16. And I'm done. So you can see it's a little bit of work sometimes when you're doing these power reducing formulas, and it takes a lot of patience. You got to be really careful with making sure you multiply things correctly and then substitute in the power reducing equation. Alright, so now let's look at some half angle examples. So if you're given the following triangle, I want you to find the tangent of theta over 2, the secant of theta over 2, 2 times the sine of theta over 2 times the cosine of theta over 2, 2 times the sine of theta over 2 times the tangent of theta over 2. I will give you a hint that the triangle is drawn intentionally in this direction, so the adjacent side is going to be -4. So this triangle is in the second quadrant. So pause the video, try to find these, unpause when you're ready to check your work. Okay, so for tangent of theta over 2, I chose to use the sine theta over 1 plus cosine theta. You could have used 1 minus cosine theta over sine theta, or you could do the plus or minus 1 minus cosine theta over 1 plus cosine theta. It's going to be the plus though, because where's theta? Theta is in the second quadrant, therefore theta over 2 would be in the first quadrant. So all of these are going to come out to be positive here. Okay, so this is what I did. Then sine of theta is 3/5, cosine theta is -4/5, and so when I simplify this, I end up with tangent of theta over 2 is 3. Secant of theta over 2. Secant is the reciprocal of cosine. So since cosine of theta over 2 would be the square root of 1 plus cosine theta over 2, I just take the reciprocal of that. So secant of theta over 2 is the square root of 2 over 1 plus cosine of theta. Now plug in for cosine of theta, -4/5, simplify underneath the root, and I end up with the square root of 10. 2 sine theta over 2, cosine theta over 2. This is the double angle identity for sine. However, the angle is a half angle, so this just equals sine of theta. Normally, you know, think about the double angle identity where we say 2 sine x cosine x equals sine of 2x. So here, my 2x is actually just theta, and x is theta over 2. The identity still works though. So what is the sine of theta? It's 3/5. How about 2 sine theta over 2 tangent theta over 2? Well, we already did tangent of theta over 2 back up here at the top. We know that that's 3. So now I just need to figure out what is the sine of theta over 2. So this becomes 2 because of the 2 times the square root of 1 minus -4/5 because it's 1 minus cosine theta over 2 times 3 because the tangent of theta over 2 is 3. Simplify underneath the root. I end up with 2 times the square root of 9 over 10 times 3. Square root of 9 over 10 is 3 over root 10. This becomes 18 root 10 over 10, which reduces to 9 root 10 over 5. Alright, next example. I want you to find the exact value of the cosine of pi 12ths. I will give you a hint. There are 2 different ways you could do this. You could use either the half angle identities, or you could use the sum and difference identities. So I want you to pause the video and find the exact value of cosine of pi 12ths using either of those methods, and unpause when you're ready to check your work. Okay, so pi 12ths is either pi 6th over 2, so pi 12ths is the half angle of pi 6th, or I can think of it as like 4 pi 12ths minus 3 pi 12ths, which is pi 3rds minus pi 4ths. So if I use the half angle, I get cosine of pi 12ths, that's in the first quadrant, so I do positive square root of 1 plus cosine of pi 6 over 2. The cosine of pi 6 is root 3 over 2. So I have the square root of 1 plus root 3 over 2 over 2. Simplify this, I end up with the square root of 2 plus root 3 over 4. So this is the square root of 2 plus root 3 over 2. I do not expect you to simplify that. You can leave your answer in that form. If I use the difference formula, cosine of pi 3rds minus pi 4ths is the cosine of pi 3rds times the cosine of pi 4ths plus the sine of pi 3rds times the sine of pi 4ths. Cosine of pi 3rds is 1/2, cosine of pi 4ths is root 2 over 2, sine of pi 3rds is root 3 over 2, sine of pi 4ths is root 2 over 2. This simplifies to root 2 plus root 6 all over 4. These two are the same thing. You do not need to manipulate one to show that it equals the other, but they are the same thing. If you don't believe me, type them into your calculator and you'll see that the values are the same. Again, either method here is correct, so now you're just learning more tools that you have. Alright, there's a few more examples I want to do, but we're running out of time on this, so we're going to have a part 2 to this. So this video is going to be done, but then go on to part 2.